Identify the reaction and the given values. Formic acid, HCHO2, dissociates in water according to the equilibrium equation. HCHO2 plus H2O is in equilibrium with H3O to the power plus CHO2 to the power negative quad. The given acid dissociation constant is Ka equals 2 times 10 to the power minus 4, and the initial concentration of the acid is 0.5 molar. Set up the equilibrium expression. Ka equals H3O to the power plus CHO2 to the power negative over HCHO2. Quad let X be the concentration of H3O to the power plus and CHO2 to the power negative that forms at equilibrium. H3O to the power plus equals X, CHO2 to the power negative equals X, HCHO2 equals 0.5 X. Solve for H3O to the power plus using the small x approximation. Because formic acid is a weak acid with a very small dissociation constant, KALL1, it dissociates to a very limited extent in water. Therefore, we can assume that the change in concentration is negligible relative to the starting concentration, 0.5, x approximately 0.5 molar. 2 times 10 to the power minus 4 equals x to the power 2 over 0.5 x to the power 2 is equal to 0.5 times 2 times 10 to the power minus 4 equals 1.0 times 10 to the power minus 4x equals square root of 1.0 times 10 to the power minus 4 is equal to 1.0 times 10 to the power minus 2 molar. Thus, the equilibrium concentration of hydronium ions is H3O to the power plus equals 1.0 times 10 to the power minus 2 molar. Calculate the pH of the solution. pH equals log H3O to the power plus quad pH equals log 1.0 times 10 to the power minus 2 equals 2. The best estimate for the pH of the solution is 2. Determine the species at the highest concentration. Excluding H2O, compare the equilibrium concentrations of the solute species. HCHO2 equals 0.5 molar. 0.01 molar equals 0.49 molar. H3O to the power plus equals 0.01 molar. CHO2 to the power negative equals 0.01 molar because the acid is weak and only a very small fraction, approximately 2%, of it ionizes. The vast majority of the formic acid remains in its intact molecular form. Therefore, the concentration of the unionized acid, HCHO2, is significantly higher than that of any dissolved product ions, 0.49 molar GG 0.01 molar. Matching a pH of 2 and HCHO2 as the highest concentration solute species identifies option D as the correct answer. The correct answer is option D, pH equals 2, and the species at highest concentration is HCHO2.